Hello my dear students and welcome to this lecture series by Dr. APJ Abdul Kalam Technical University, Lucknow. I am Dr. Supriya Latpam, an assistant professor in the Department of Civil Engineering in BBD ITM. I will be taking unit 3 for you for the unit 3 for the subject environmental engineering with code KCA 603 and this is my 5th lecture. In the first 4 lectures, we have talked about the physical, chemical and bacteriological characteristics of water. In today's lecture, we will be I will be taking a short slide, I will be talking a little bit on waterborne diseases. After this, we will move to the codes. So, in waterborne diseases, why was we have in the last slide we have talked about bacteriological characteristics, like why we have to check if some fecal bacteria were present, fecal coliforms were present in the water or not. So, what if it is present, what will happen? They will cause this waterborne diseases, and now with the increase in the since we are very technologically developed now, we do not get such types of waterborne diseases, but some places also where it is not developed, we see that many small children are dying because of these diseases. Okay. So, what are those diseases? The most common diseases are waterborne diseases means those diseases which spread primarily through contaminated water. So, when you drink contaminated water, you have these diseases. So, what the diseases caused by bacterial infections? They are typhoid fever and paratyphoid fever caused by typhoid fever and paratyphoid fever caused by Salmonella typhi bacteria. Then another is cholera caused by Vibrio cholera bacteria. Then dysentery, bacillary dysentery caused by Shiga bacillus or Flexner bacillus or Sonne bacillus. Another disease is caused by viral infections. They are the most common are infectious hepatitis, which is actually still very prevalent, infectious jaundice caused by hepatitis bacteria. Another is poliomyelitis caused by poliovirus. It is almost wiped out of India right now, but still we have to be very careful. Then another is disease caused by protozoal infections, amoebic dysentery. So, you people must have heard ki people are lots of people are having this amoebic dysentery. They are caused by Entamoeba histolytica. So, with this we have finished waterborne diseases. Now, let us talk about a very important thing. So, today we are going to talk a little bit about the specification, that is the drinking water standards for our drinking water standards. So, in India the drinking water standards is given by the code IS 10500 2012, that is drinking water specification. So, you can it is easily available in the internet and you can download it. So, this what does this code do? It tells you ki what are the limits within which it is safe for drinking water. What are the limits where we can have this metals and we can have this whatever limits, these are limits. So, whenever you see this limits, you will have two here. One is the acceptable limit, another is the permissible limit. Acceptable limit is in the sense that generally this is the level where it is generally acceptable, like you can use that water. Another is the permissible limit, means permissible limit is in some extreme cases you may go for this level, but after this level the water is not going to be potable, the water you cannot drink those water. Okay. So, you always remember, so you cannot exceed the permissible limit. So, we have colors in Helsinki units 5, 15, order should be agreeable, pH value should be between 6.5 to 8.5, there is no relaxation. After 8.5 it is going to be too alkaline, before 6.5 it is going to be too acidic, taste would be agreeable, turbidity should be between 1 or maximum should allowable is 5 NTU, TDS should be 500 to 2000, up to 2000 you should not drink those types of water. Then now let us come to this metals, aluminum, we have a limit for aluminum, we have limit for ammonia, you have for anionic detergents, you have for barium, for boron, for calcium, calcium is 75 and 200. Then you have for chloramines, then you have for chloride. We have talked about chloride, the limit was 250 and 1000 ppm. So, after 1000, that water, if the water has 1000, more than 1000 ppm of chloride, that water is not acceptable. You cannot drink that water. Copper is 0.05 and 1.5. After 1.5, you should discard that water, you are not supposed to drink it. Then next is fluoride. Fluoride should be between 1 and 1.5. After 1.5, you should not drink it, right. Then the residual chlorine in the sense that when we have drinking, when we go for water treatment, we include chlorine in the water because it is needed for disinfection. So, the free chlorine presence should be between 0.2 and 1. Iron is 0.3. After 0.3, there is no relaxation. Then we have magnesium, we have manganese, we have mineral oils, nitrate. We have already discussed nitrate, that it is 45 and there is no relaxation. After 45, you cannot have more than 45 ppm of nitrate. Then phenolic compounds. Similarly, we have selenium, we have silver, we have sulphate. Sulphate is 200 to 400, we have sulphide, then total alkalinity as calcium carbonate 200 and 600, total hardness as calcium carbonate 200 and 600, and zinc. So, these are the at the same time there are some toxic substance for which these limits are given. This is the acceptable limit, right, and there is no relaxation in this. So, this toxic substances, the toxic compounds, toxic metals are cadmium, cyanide, lead, mercury, molybdenum, nickel, pesticides, polychlorinated biphenyls, right. These are the limits. So, you can have a maximum of this, afterwards that water is not acceptable. Okay. So, these are some of the toxic substances, metals, some compounds. Similarly, we have polynuclear aromatic hydrocarbons, arsenic, see this is a limit, chromium, then we have trihalomethanes, that is bromoform, dibromochloromethane, bromodichloromethane, chloroform, etc. right. So, with this we have wrapped up water, drinking water. So, you should have an idea about the drinking water standards, which you can get from IS, from the code IS 10500 Now, with this we have finished the physical characteristics, the chemical characteristics and the bacteriological characteristics of water. At the same time, we have talked about little bit about the codes, like what is the permissible limit for water. Now, let us move to the next topic, that is wastewater. Similarly, as I already told you before in my previous videos, that wastewater is actually water. Wastewater and water both are actually water. Wastewater is what? You can say this like used water, right. You have already used that water, but it is actually water only. So, the physical, chemical and the bacteriological characteristics are going to be similar, not same, but similar. So, but especially the physical characteristics. Okay. So, here we are going to first we have finished water. When I say water, I am saying about drinking water or potable water. Now, let us come to the physical characteristics of wastewater. So, wastewater, when you talk about what is wastewater? So, first let us discuss that. What is wastewater? Water, when used for different purposes like domestic, commercial, industrial, receives impurities and become wastewater. Thus, wastewater is used water. Okay? Used water. You have already used that water in some manner. You may have used it in your homes, you may use it in some industry or some other, and in some complexes, whatever it may be. It may come out as effluent from industries, it may come out from your home, from your kitchens for cooking, right, for taking bath, right. So, and it has physical, chemical and biological impurities in it. Okay, right. So, now we are going to focus on. Now, a little there is little shift in the little shift when we talked about water and wastewater, and with wastewater we will talk a little bit, we will start seeing things with a different view than wastewater than water. So, physical parameters, when you talk about physical parameters, obviously I already told you what are physical parameters, like those things which you can feel, you can touch, you can smell, right. So, physical parameters define those characteristics of wastewater that respond to sense of sight. You can see it, you can touch it, you can taste it, and you can smell it. Obviously, those are suspended solids. We have already discussed this in water, but I will just wrap up a little bit, go very fastly for wastewater. Turbidity, color, taste and odor, and temperature. Now, suspended solids. So, obviously, when you talk about wastewater, you are going to see a lot of suspended solids, lots. Okay. So, and it is actually, see, whatever you see in your drains is actually a wastewater, right. So, you are going to see. So, suspended solids suspended in water may consist of inorganic or organic particles or of immiscible liquids. Inorganic solvents such as clay, silk and other soil consequences are common in surface water. Organic matter may be plant fibers and biological solids, algal cells, bacteria, etc., are also common constituents of surface water. Other suspended material may result from human use of water. Domestic wastewater usually contain large quantities of suspended solids and that are mostly organic in nature. So, say for example, say we have talked about solids in water, but here we are talking about in wastewater. So, obviously, you will going to see when you talk about wastewater, you are going to see lots and lots of suspended solid. Industrial use of water may result in wide variety of suspended impurities of either organic or inorganic nature. Immiscible liquids such as oil and grease are often constituents of wastewater. Suspended materials are objectionable in water as it is aesthetically displeasing and provides absorption sites for chemical and biological agents, right. So, suspended solids. With this we wrap up suspended solids. We will be talking a little bit more on solids in the chemical characteristics part. Now, turbidity. Turbidity, obviously, when you talked about wastewater, when you talk about sewage, you expect it to be turbid, you expect it to be dirty, right. So, sewage is normally turbid. It has floating materials like fecal matter, pieces of paper, grease, vegetable debris, etc. Degree of turbidity can be measured by turbidity rods or turbidity meter. We have already discussed about this we have talked about turbidity rods and turbidity meters in the physical characteristics of water. So, similar like that, and actually turbidity is not an issue for wastewater, because you do obviously you expect wastewater to be dirty, right. But when you talk about potable water, you do not expect any turbidity, you want clean clear water to drink, right. But for sewage there is no consideration as such. Color. The color of sewage can be normally detected by naked eye. Okay, you can see if it is sewage or not. Color of sewage indicates the freshness of sewage. Okay. So, when the sewage is fresh, or as you can say fresh, then the color is going to be grayish, brown or yellowish, right. General, I am talking about general, not about talking about some sewage coming out of a particular industry which has some particular color. Generally, it is supposed to be grayish, brown or yellowish. With passage of time, as putrefaction starts, it begins to get black. So, what will happen? The sewage or the sewage wastewater is going to have lots of organic matter, and there is going to be there is going to be degradation, biodegradation going on. So, once the biodegradation going on, the color is going to change into black, right. Some other color may also be formed due to presence of some specific industrial waste. Okay. Taste and odor. Obviously, you expect wastewater or sewage to be very smelly, right. So, what is it? The odor of fresh sewage is not offensive. When it is fresh, it is not supposed to be very offensive. It is going to be a little bit offensive, but it is not going to be very offensive, or practically it can be considered odorless. But as it starts to get stale, it begins to give offensive smells, odor. So, what will happen? So, in fresh you will not have much problem with smell, but once that once degradation happen, it is going to start smelling really bad. Why? Because of some gases. Within 3 to 4 hours, all oxygen present in the sewage get exhausted and it starts emitting offensive odor by hydrogen sulfide gases, which is formed due to anaerobic decomposition of sewage, right. So, once the aerobic till the aerobic degradation is taking place, there is not going to be any bad smell as such, right. But once this anaerobic, once the oxygen gets exhausted, once the oxygen is used up, then what will happen? The anaerobic bacteria will start working, and once this anaerobic bacteria start working, they are going to emit hydrogen sulfide gas, which is going to smell like rotten eggs, very bad smell. It can be measured by threshold odor number or TON. We have already talked about it, and it represents the extent of dilution required to make the sample free of odor. Now, temperature. Temperature is actually very important when we talked about wastewater. It is actually very important. Why? Because when we talked about wastewater, we are also dealing with degradation, like the organic matter which is going to be present in the wastewater is going to be degraded, right, and that degradation is actually very much dependent on the temperature. So, when you talked about in India, as the temperature is quite high, prevalent temperature is quite high, around 20 degrees centigrade, right, the water temperature. So, those bacteria can they can work at their optimal level, but when we talked about European countries where the temperature is very low, those there it is going to be a problem, right. So, temperature has an effect on the biological activity of the bacteria present in the sewage, and it also affects the solubility of gases. So, biological effect, the solubility of gases. Solubility of gases, when we talked about, what were we talking? We are talking about oxygen, right. So, sewage in the sense that it is going to be wastewater. So, wastewater is actually water. So, wastewater will have oxygen, which is going to be diffused from the atmosphere. So, this oxygen is DO, right. So, solubility of gases in sewage, it also affects the viscosity of sewage. More is the temperature, lesser is the viscosity of sewage. The normal temperature of sewage is slightly higher than the temperature of water supply because of the additional heat due to utilization of water. Also, when wastewater flows in a closed pipes, its temperature further increases, right. The average temperature of sewage in India is about 20 degrees centigrade, which is near the about ideal temperature for sewage for biological activities. So, all our biological activities, all the sewage treatment plants in India is going to work fantastic, like it's very good, like the temperature is ideal. So, you should get very good results. Okay. At highest temperature coupled with lower dissolved oxygen and activities can cause serious problem in disposal of wastewater. So, what will happen when if temperature is high, that also will create problem. If temperature is low, that also will create problem, because what are we talking about? We are talking about here bacteria, right. Right. So, bacteria is also a living organism, right. They are comfortable at right temperature, which, right, if it is a lower temperature, then also they will have problem, and at higher temperature also they will have problem. So, this is the ideal temperature. India fortunately has an ideal temperature which will be very which is very helpful to this bacteria. Now, let us come to the chemical characteristics. So, what we have talked about is, we have talked about the physical characteristics of wastewater. Now, we are talking about the chemical characteristics of wastewater. The chemical characteristics of wastewater and the chemical characteristics of water are similar, Okay. But when we talked about wastewater, we are also going to include some more terms and exclude some more terms, right. So, here when we talked about chemical characteristics, we are not going to talk about hardness, we are not going to talk about alkalinity, right. At the same time, here when we talked about chemical characteristics, we are going to add up some things like fats and greases, sulfides, right, dissolved oxygen. It was there, but we are going to study a little more, and then two more very important terms are going to come up, which is going to be the biochemical oxygen demand or the BOD and the chemical oxygen demand, that is the COD. So, when you talk about chemical characteristics or when you talked about wastewater, the most important term is going to be this. Your treatment, whole your treatment will be dependent on the biochemical oxygen demand or the as you can say BOD, right. So, let us move one by one. So, first we have talked about the solids. So, we have already talked a little bit about solids and physical characteristics. Now, we are going to talk about the solids in chemical characteristics. So, in chemical characteristics, we are going to talk about total solids, suspended solids and settleable solids, right. Sewage is actually 99.9% water and around 0.5 to 0.1, 0.05 to 0.1% total solids. So, it is actually mostly water with small amount of solids, okay, but that is going to look really bad. It is not going to. So, when we talked about solids, we are going to talk here about four terms. The suspended solids, what are? They are those which are solids which are remain floating in sewage, which float, right. Dissolve is, we have talked about it in water also. Dissolved solids, they are those which remain dissolved in the sewage or in the water, right. Colloidal solids, they are finely divided solids remaining either in solution or in suspension, right. And settleable solids, they are those that portion of solids matter which settles out if sewage is allowed to remain undisturbed for a period of 2 hours. Okay. So, we know what is suspended, we know what is dissolved, we have talked about a lot about it in water. Let us talk about colloidal solids. The most common example of colloidal solids which you commonly see is what? Milk, blood. Both milk and blood are colloidal solids. Okay. But when we talked about when we as environmental engineers, we as civil engineers, we are not very concerned with this, even though it is there. So, we will sort of forget about this. Okay. At the same time, with this settleable solids is very important. Why? Because it is something which is settling, like. So, when we talk about treatment of wastewater, we are going to talk about sedimentation tank, and that sedimentation tank, this settleable solids is going to matter a lot. So, for settleable solids which is settling. So, for this I think you people must have heard the word called Imhoff cone. What is the Imhoff cone? Here Imhoff cone is a cone which looks like this, almost a cone, triangular like this. You have graduations here. Okay. So, what you do is you put wastewater in this and keep it undisturbed for a period of 2 hours. Okay. When you keep it undisturbed for a period of 2 hours, what will happen? The settleable solids will settle down. Okay. After 2 hours, you will see through this reading. This reading will tell you ki, how much solid is there in particular 1 liter or 2 liter of wastewater. Okay. So, this is the settleable solids. Now, let us talk about this solid analysis. This diagram will show you completely how to determine all these things. Okay. So, once you have the sample, this is the sample, what will happen? You dry the sample in a petri dish, right, at 103 to 104, actually it is around 104 degrees centigrade, right. When the water goes out, whatever leaves whatever you have will be total solids, right. Then if you dry this total solid in a muffled furnace, or else you can say if you burn it in a muffled furnace, at 550 degrees centigrade, whatever will evaporate is the volatile solids and whatever will remain is the fixed solids, right. Then another part of this sample of this water, if you filter it, whatever remaining here is going to be the suspended solid, right. And if you dry this, obviously if you dry this, you get suspended solids. Again, if you put it in a muffled furnace at 550 degrees centigrade, whatever is evaporated will give you the volatile suspended solids, and whatever is remaining, right, in that crucible is going to be the fixed suspended solids. Similarly, whatever is left after filtration, if you dry it, water will evaporate, right, and whatever will remain is going to be the dissolved solids, and whatever is and if you again put it in the muffled furnace at a temperature of 550 degrees centigrade, then whatever is going to remain is going to be the fixed dissolved solids, and whatever will be evaporated is going to be the volatile, right. So, all these suspended solids, dissolved solids, all these things or your total solids, right. These all of this is going to have two terms here. One is going to be the volatile, another is going to be fixed. So, volatile means what? Sorry, fixed. Another is going to be fixed. So, what is volatile? Volatile is that part which is going to be as you can say, it is going to fly out, right, and fixed will be what part which is going to remain, which is going to be. So, volatile is it volatilizes in the air. Okay. Thank you. With this I finish my with this I have finished solids in for wastewater, and thank you for listening to me. Have a very good day.